Good evening, all. I will share the screen now. Is there any doubt in the previous lecture? So, there was one question previously regarding SO3H group and NO2 group. So, electron withdrawing ability of NO2 group will be more because of the electronegativity of nitrogen is greater than that of the sulfur. So, the negative inductive effect of NO2 will be more compared to that of SO3H. Okay, that was one of the question or doubt that was remaining in the previous lecture. So, can we start? Um, Please mute yourself. Hello. Welcome to week 3 assignments of the NPTEL PMRF tutorials of the course Introductory Organic Chemistry 2 by Professor Harina Chakravani and Professor Neeraja Deshaputre. Myself, Anisha Suresh, PMRF TF for this course from IIT Bombay. So, coming to the summary of the week 3 modules. So, in week 3, basics of carbonyl compounds was discussed, followed by addition reaction on carbonyl functional groups and nucleophilic addition reaction and its stereochemistry. So, coming to the basic of carbonyl compounds. So, for addition reaction to take place on the carbonyl compounds, it requires two mechanistic steps. First will be the nucleophilic attack on the carbonyl group, followed by protonation of the anion that will be resulting. Okay, so we can see the mechanism. As we can see here, uh, this is a carbonyl group which is the acetone and Cn minus as shown here NaCN H2SO4 H2O. Here NaCN Cn minus will be the nucleophile. So the Cn minus will attack on the carbonyl functional group and this carbon oxygen bond will break and this electron pair will move towards the oxygen. So this is the first step, that is the nucleophilic attack on the carbonyl group. Now an O minus group is generated which will abstract proton from the medium because H2SO4 and water is present, so it will result in the formation of H3O plus or proton will be present in the medium. So protonation will be taking place and we will get the cyanohydrin. So this compound which is containing Cn and OH is known as cyanohydrin. Okay. So this is the basic mechanism of addition reaction to carbonyl compounds. Now, uh, when we discuss the molecular orbital picture of this carbonyl compounds, so we can see this is methanol. There is carbonyl C double bond O and this carbon is bonded to two hydrogen atoms. So we can see how the bonding is taking place. So this is a planar compound. The angle is 120 degree. So we can see here. So the carbon will be having sp2 hybridization, the oxygen will be having sp2 hybridization. So one of the sp2 hybridized orbital of carbon and oxygen will combine, resulting in the formation of this sigma orbital. So CO sigma bond made up of two sp2 orbitals. So since this is a planar molecule, it will be having sp2 hybridization, sp2 hybridization. So one of the sp2 hybrid orbitals of both the carbon and the oxygen will combine, resulting in the formation of a sigma bond. So this is the sigma bond that is resulting, and the carbon will be having two more sp3 sp2 hybridized orbital. It will combine with the orbital of hydrogen, resulting in the formation of sigma bond, ch sigma bonds. And here the remaining two sp2 hybridized orbitals of oxygen. Hello, Rebindra, can you please mute yourself? Hello. So the remaining two sp2 hybridized orbitals of oxygen, it will be remaining it will connect the lone pairs. Okay. Then if we are considering about the pi bonding in formaldehyde, then we should first discuss regarding the orbitals. So the since oxygen is electronegative, it will be having lower energy. Carbon will be little higher in energy. So there will be one electron each in oxygen and carbon. So it will combine, resulting in the formation of uh, pi orbital and pi star orbital. So the pi orbital will contain the electrons, the pi star orbital will be empty. As you can see here, the pi orbital is closer in energy to that of the oxygen, hence it will have major contribution from oxygen. And the pi star orbital is closer in energy to that of carbon, it will have more contribution from the carbon. So we can see the pi bonding in formaldehyde. Excuse me, Rebindra, can you please mute yourself? Hello? Hello? So, for pi bonding in formaldehyde, as you can see here, the major contribution will be from oxygen. So, the orbitals in oxygen will be um, having more contribution than that of the carbon. So, this is having bigger orbitals compared to carbon. Uh, and now coming to anti-bonding orbital, it is having more contribution from carbon. So, here the carbon orbitals is bigger compared to that of the oxygen. So this is the filled pi orbital, and this is the empty pi star orbital, and we have seen this is the filled sigma sp2 orbitals. So it will result in the formation of the c double bond o bond. Clear? Hybridization and all. Now coming to addition reaction on carbonyl functional group, so we can see here this is a carbonyl functional group, and Cn minus is added, resulting in the formation of the cyanohydrine. So here this compound, after addition of Cn minus, it is generating a new stereogenic center, which is a chiral center. So here four different groups are there at the center. So this center, where after addition a new stereogenic center is generating, is known as prochiral center. Okay, the center is known as prochiral center. And in the case of acetone, after addition of Cn minus, we are getting a compound which is not chiral. So this center where the Cn minus addition is taking place is not prochiral. So if the addition is resulting in the formation of a new chiral center or stereogenic center, that center is known as, hello.
And can you maximize the slide?
Yeah, yeah. Someone have shared their screen. That is why I will share again. Okay, just wait 1 second. There is a problem in sharing. Just I will resolve it.